Doing every challenge question, part 35, Corporeal 1, chapter 3. It's the chapter on series. So, okay, I did this question probably quite a weird way. The first thing to do, obviously, is to break this sum from n to 2n up into sum from 1 to 2n. Take away the sum from 1 to n minus 1. So this will now include every object up from up from n to 2n, because I'm taking away all the ones below n. So that's good. And then I decided to split this up more by doing the sum of this of 12 minus the sum of 2r, and so on. You can also put the 2 out the front here, because now, and the 12 out the front as well, I guess, because now you can just use standard results for everything. So the sum of 1 is just this number here, 2n, and the sum of r is a half of r into r plus 1, where r is whatever's this top number here. So this one here will be a half into 2n into 2n plus 1. So that's what I've said here. And likewise here, and likewise here, and likewise here. Two negatives make a positive. Notice there's probably far easier ways to do this. Anyway, lots of stuff cancels, lots of stuff goes together, lots of stuff now goes together some more. You divide everything by 3 and you factorize, and you find the solution is at n is 4. N is minus 1 doesn't make any sense because you can't take the sum from minus 1 to minus 2. So n is 4 here. Next question I've also done in quite a weird way, I think. I'm not really sure how you're supposed to do it. So what I decided to say was, well, the sum of r is this, as I said in the previous slide, which is actually kind of this, which is kind of quite close to n squared, in the sense that this is a polynomial, it's just r, and it sort of makes the thing that they want me to get. So all I'm going to do here is just adjust this in order for it to make the thing they want. So the obvious thing to do is times everything by 2. So the sum of 2r is therefore n squared plus n. And now I just need to drop the n. But I know how to make n. I just sum up the number 1 from 1 to n. That makes n. So if I just remove that from this sum here, I should just get n squared. And indeed, that's exactly what I get. So the function, the polynomial I need, is just 2x minus 1, and that will do it. And I'm just going to do the same thing for these two questions here as well. I'm going to consider the sum that gets me the right degree polynomial. So this sum here gets me a degree 3 polynomial. If I times it by 6, that will make it a bit better. I'm still got this and a 2 here that's all wrong. So what I'm going to do is I'm just going to say, well, n squared, I know how to make n squared. That's using this sum here. So if I just remove 2r minus 1 away from this, and actually times that by 3 at the same time, so remove 3 lots of it, I'll be removing this exact object. And then if I remove another 1, I'll be removing this object. And that will make me the 2n cubed. And then I just need to divide everything by 2. And I'll end up with the exact object I need. So divide this by 2. Sorry, this is what I just used to get from here to here, of course, and I put that in there. Now tidy this up and divide by 2. And you end up with this object here. So this is the f3x that I need to sum to n cubed. So that's quite nice. And then f4 of x, same idea. So use the cubic sum to get you a degree 4 polynomial, times over by 4 to get rid of this fraction. Expand this thing out. Remove 2 copies of the thing that sums to make n cubed, which I already have. It's this thing here. So remove 2 copies of that. Remove a copy of the n squared thing, which was this here. And simplify all of this up, and you get the sum of this thing here. And so that will be my f4 of x, and that will all be done. So cool, that's good. Hence show that any linear, quadratic, or cubic polynomial. So how do I represent anything like this? Well, I can just write this, because if a is 0, or b is 0, or c is 0, or 3, I guess, then you end up with these things. That's fine. This is representing them all. Of course, h of n is just this thing with n's put in it, and then nh of n is just times everything by n. So you end up adding a degree to the polynomial like this. And now I'm just looking for something that sums to make this, but I already know how to make n to the 4. That's the sum of this polynomial. And I know how to make n to the 3. That's the sum of this one. And n squared is the sum of this one. And n, you just use the sum of 1. So I think this is just the sum of a lots of f4r, b lots of f3r, and so on. And then to make n, you just sum up 1. So I could have written a 1 here, but it doesn't really matter. So I think that equals that. And now, basically, this is just a polynomial, this whole thing, which I can just call g of x, I guess. And that'll be the thing that does it. I think they're leading me on to some, like, interesting thing with this, but I don't really understand what it is. I don't really get it. But that's how you do it. Maybe you can write in the comments what's actually interesting about this. I don't really understand. Anyway, these last two questions are nice because it's just getting out some algebra and doing it. So the sum of r squared is this result here, so just plug in some i's. Expand all this out and factorize out the sixth, and then just do the sum of 2 lots of I cubed, 3 the sum of I squared, and I, and so on, because we have the results for I cubed, we have the results for I squared, we just used actually, and we have the results for I, so we can put all those in, like this. This is the sum of our cubes, so that goes in there, times it by 2, and you make the quarter into a half. This one goes in here, times by 3, also make this into a half. And then the sum of I is just a half n into n plus 1, as I said a few times in this video. Factorize out the half, factorize out an n, factorize out an n plus 1, because they all have that, and you end up with this. And then tidy up this inner bracket here, and you end up with this. That factorizes to make this, which you can then tidy up exactly to make the thing they wanted. And we'll do a very similar thing for this last one as well. So the sum of r is just, of course, half I into I plus 1, if I is at the top here. Now, factorize out the half because we don't need it. This is I squared plus I. Break that into two sums and use this result for the first one. And this is again just a half into j plus 1. This result being used here. Factorize out a sixth to turn that into a 3, I guess is probably what I've done here. And then I think I just expanded all of this out because I was aiming to do the final sum here. So this ends up being 2j cubed, 6j squared, and 4j. So you can break those into 3 different sums. You can use these two results, and finally the half n into n plus 1 result as well, which I never actually wrote down, but cool. You can use all of those 3 results here to get all of this. Factorize out half to make this a 24th, which is what I want. Factorize out an n, factorize out an n plus 1, and you get all of this. If you factorize out half, this ends up doubling, and so does that, so that's cool. And then, yeah, just, then factorize out the n into n plus 1 again. Like I said, I think I said to do that, but yeah, do that again. And tidy up this thing in here, which eventually turns into this, which factorizes into this, and you're all done. Thanks for watching. I'll see you next time.